Good morning, students. Hope you all are doing well. And as you know, in our physics, we are continuing spherical mirror. Spherical mirror are convex mirror and concave mirrors. As you know that we are continuing that. So we'll continue that portion. Okay. We'll continue that portion today. First of all, come on, you join first, then we'll start. Come on, join first. In spherical mirror, we discussed about convex mirror and concave mirror. We'll continue that portion. First, join first. Good morning, all of you. Come on, start. Join first, so that we can start. Achha, one question to all of you. Are you getting notification of this live classes in your mobile? Like when I start, do you get notification? Who are not getting notification? Who do not get the notification? Okay. Where the others? Like I can see few are joined. Where the other side don't know. Where the other students? Okay. As you know that spherical mirror is a very important portion, and in spherical mirror I shared 3 videos with you. Okay, 3 videos. There we discussed about convex and concave mirror. We discussed different terms of convex and concave mirror. After that I shown you different type of ray diagrams which are very important. Okay, these ray diagrams are very important. This ray diagram, today we'll see the part which is called sign convention. Okay, the part which will be discussed today is called sign convention. What is that? It's very crucial part of this chapter, of this portion, spherical mirror. Very crucial. Okay, so I will discuss that, you understand it, and wherever you will have doubt, please write in the comment that this portion I didn't understand. This portion is very crucial. Okay, like first I will draw a convex lens, not lens, we are doing mirror. First of all, I am drawing a concave mirror. As I told you in those videos, that mirror, the front portion should face our left hand. Okay, mirror always, this is the rule of physics. I told you, always the front portion of the mirror should face the left side of your hand. Okay, left side. Now if you draw a mirror, like you get focus point, you get center of curvature, and center of curvature and focus point is always the midpoint of center of curvature and optical center. You know that See this figure. All of you just answer me. Is it clear to you? Is this portion clear? Can you see it? Just write in the comment clear or blur. So this is the mirror. This mirror, and this is called principal axis, center of curvature, focus point. So focus point is at the midpoint of center of curvature and optical center. Okay. Now, try to understand what I'm saying. You are standing in front of a plane mirror. Okay. You are standing in front of a plane mirror. Fine. So this is the mirror. Say this is my mirror. Okay. This is my mirror. Here I'm standing. And where you see the image forms just behind the mirror. Okay. Image forms behind the mirror. Means my distance from the mirror is equal to the distance between image and the mirror. This is for a plane mirror. Understood? And in plane mirror, what is the height of me and what is the height of my image? Both are same. Understood? Height of me and height of image, both are same in plane mirror. But in case of a concave mirror or convex mirror, the things become opposite. The height of the object and height of the image may same or may not same. Okay. May same, may not same. Not only that, the distance of the object and distance of the image may same, may not same. Different position. Okay. So I want to tell you that, say I am keeping my object here. Say this is my object. Try to understand. It's a very, as I told you, this is a very crucial part of this portion. Understood? So this is my object. Okay. This is my object. Where I'm keeping my object? Here I'm keeping my object. So that is not correct that you will get your image here, like plane mirror. In plane mirror, if this is a plane mirror, here you are keeping the object and you will get the image here at the same distance. So this will be the image in case of plane mirror. But since this is a concave mirror, this is not a plane mirror. So where you will get the image, that depends. You know from the third video. The third video I showed you where you will keep the object, where you will get the image. Everything we discussed. So here, this is my object. Where you will get the image, that depends. Okay. So you may get the image here or here. So this is my object. This is my object. You are getting image here or here. Anywhere you may get. So this is my object. This is my image. This is my image. Understood? This is my object. Try to understand, all of you. This is my object. This is my image. This is my image. Means anywhere the image form can form. Why I have drawn two images? Because image may form here in front of the mirror or image may form back of the mirror. Anywhere it will form. Okay, anywhere. Either this side or that side. Either in front of the mirror or either back of the mirror. Anywhere it may form. Okay. Now, we know that object distance or image distance always we measure from the optical center. Got it? So in this way, I can say that this is my U and this is my V and this is my V. Try to understand what is U, what is V. See, this is U. U is the object distance, the distance between object and the pole. This is called pole. Pole and the object. This distance is called U, object distance. And if this is image, then the distance between image and the pole, This distance is called image distance. If this is the image, then this is called image distance. But if this is the image, then the distance between image and the pole is called image distance. See, V. So either this is U, this is V, or this is V. Because image may form in front of the mirror or image may form back of the mirror. Okay, back of the mirror. So anywhere the image may form. Understood? And if this is the image, then this is the image distance. If this is the image, then this is the image distance. And object distance we know. Okay, so we know object distance, the distance between object and the pole. Image distance is the distance between image and the pole. So this is the figure you have seen. Okay, now the important thing is, a mirror is given, the left side of the mirror is always negative part. Okay, always negative part. And right side of the mirror is always positive part. Positive part. So in this way we have to decide something. Now see, this side is negative part and this side is positive part. Okay, negative part and positive part. So my object is here. This is my object. I cannot place my object here. What is the benefit of standing behind a mirror? There's no benefits. I cannot place my object here. I can place my object here. So this is my object distance. U is my object distance and this is in negative side. That means object distance is negative. Okay, object distance is negative. Understood? Now this is V. If this is the image, this is V. Okay, this is V and V is negative. But if this is the image, then this is V. This is positive. Sorry. So what I told you, if this is your image, then this is your image distance, which is negative. If this is your image, then this is image distance. Then this is image distance, and image distance is always C, positive. Understood? So we saw that object distance is always negative, but image distance may positive also, negative also, or positive also. Okay, understood? From this diagram, object distance is always negative. Okay, as I told you, in front of the mirror is always negative side. Okay, and back side of the mirror is positive side. So we have to understand all these signs very clearly. Sign, that's why it is called sign convention. So positive side and negative side. So object always will place in front of the mirror, means negative direction. You can see, always will place in front of the mirror. Okay, in front of the mirror, so negative direction. And image may form in front of the mirror or back of the mirror. Okay, image may form in front of the mirror or back of the mirror. If it is forming in front of the mirror, then B is negative. If image is forming back of the mirror, then image distance is positive. So I will write like this. My all of you write. I'm not writing. You write it. Take out your physics copy and write it. First of all, you draw this diagram, the whole diagram, whatever I have drawn. This whole diagram, this negative, positive also you mention. Draw it. First you draw this, after that I'll tell you what to write. Okay, so this is the figure. This is the figure. I hope you have drawn. Now, all of you write object distance. Write object distance. In bracket you write u. Okay, u. Object distance in bracket you write u equal to negative. Write negative. Okay, next line. Image distance in bracket you write v. Image distance in bracket you write v. In bracket you write v equal to negative. Okay, if this is the image, then see image distance is negative because it is negative side. Okay, next line you write image distance equal to image distance in bracket v. Image distance in bracket v equal to positive, because image distance may positive also. We saw that. See, if this is the image, then this distance is positive image distance because this is in positive side. Okay, so image distance in bracket v equal to positive. Okay, now one question to you, one question for you. Just can you answer me that if I get the image here, then what is the name of this image? We have got a special name of this image. If we get the image here in front of the mirror, I told you in the third video, which I have shared with you, the third video, I told what is the name of that image. This image I am talking about, this, when you are getting in front of the mirror, this image, what is the name of this? I got one answer. Said real image, real. Let's see. What is the name of that image? Someone also told the real image. Rito Broto, Rishi Raj, Ankit Gupta, they all are saying Darika Singh. Okay, Srijade, yes. This is called real image. Okay, so can you say that? So can we say that when my image distance is negative, then it should be a real image? Okay, can I say that? So I got the answer. Who are sending? Like Irfana Khatun, then Piyush Agarwal, Tanisha, Samriddha, Lizzie, Lizade, Khushbu, Srijade, Darika Singh, they all send me the correct answer. Yes. Neha Yadav. Yes. So this is called real image. So can we say when image distance is negative, then the image is real image? I repeat, When the image distance is negative, it's a real image. Okay. So when the image distance is negative, it's a real image. But when the image distance is positive, it's a what image it is? When the image distance is positive, means back of the mirror it is forming. I told you in the videos, when the image is forming back of the mirror, this is called virtual image. Rishiraj told correctly. Virtual image, yes. This is called virtual. Correct. Now, where you have written image distance in bracket, you mentioned V and then you said negative. No, when image distance is negative, just beside that you write real image. Write it down. Where you have written V in bracket, you wrote V in image distance V equal to negative, where you have written in beside you write real image, where negative, and where positive, in case of positive you mention virtual image. Don't forget it. Virtual image. Correct. Samadrita told, then Irfana Khatun, Liza De, Sneha Yadav, all are saying okay. Samriddha also told, this is virtual image. Yes, virtual image. So when the image distance is negative, it's a real image. When the image distance is positive, it's a virtual image. I hope you are cleared with this concept. Any doubt, ask me. Any doubt. Because we are going to discuss more on this sign convention. A lot of things are left. We'll discuss that. So if you have got doubt in the at starting only, you won't be able to continue. So if you have got any doubt, just message me. Okay. Now, so object distance, image distance is done. Object distance, image distance, they are done, and we got real image and virtual image also. Okay, real image and virtual image also. When V is negative, it's a real image. When V is positive, it's a virtual image. Fine. Now, say this. See this figure. Acha, one question I think I've got. Rishiraj asked me, sir, if the image is formed at pole, then positive or negative, image you cannot form at pole. Okay, for any condition, the image will not form at pole. Okay, you might have seen, Rishiraj, if you have seen my third video, you will you might have noticed that I have changed the position of the image. Okay, see, formation of image. All of you, listen me very carefully. Formation of image. Samadrita also written to one question. I'm coming to you, Samadrita. Wait, let me answer this Rishiraj Agarwal's. So what I want to say you that to obtain the image at pole, you have to keep your object at pole. But it is not possible that keeping the object at pole. Okay. If you break it, if you break the mirror, then only it is possible. But if you break the mirror, who will form the image? So useless. Understood? So when you are placing your object at pole, then only you will get the image at pole. But placing the object at pole, it's not possible. That's why you will never get the image at pole. Understood? Okay, this was the answer of Rishira's question. Now let's see what Samadrita said. Samadrita said, sir, that when we have an object in between two mirrors which are perpendicular to each other, that part I have not understood. Okay. That too we discussed like 2-3 days before. No problem, I will answer you. Like say when you are going to a parlor, I do not know about ladies parlor, it might be same as gents parlor only. Like if you go to a gents parlor, say you are going to a gents parlor, you will see that um, that this side is the mirror, okay, and this side is also mirror, okay. Oh, she's sir, that we when we have mirror each other, that part I have not. Acha. So parlor, that both the mirrors are parallel to each other. But here you asked about both the mirrors are perpendicular each other. See this way, this way. Okay, like say this is a mirror. Okay, this is a mirror and this is another mirror. See, both the mirrors are perpendicular to each other. See, both the mirrors are perpendicular to each other. Understood? So when both the mirrors are perpendicular to each other and you are standing somewhere in between, okay, you are standing somewhere in between, then you will get the image. You can see because you are standing between the mirrors and you will get the image. Now the question is that how many images you will get? You know the formula 360 by theta minus 1. 360 by theta. What is theta? Theta is the angle between two mirrors. Theta is the angle between two mirrors. What is the angle here? 90 degree, because you said perpendicular. Okay, perpendicular. Theta 90 degree, 360 by 90 degree minus 1. 360 by 90 means 4 minus 1, 3. So you will get 3 image. Samadhita, if you stand in between two perpendicular mirror, you will see 3 more Samadritas. Understood? Understood, Samadhita? Just answer. Or any other doubt, you can ask me. Any other doubt, you can ask me. Samadhita, if you had answered, if you have understood this, just answer. Okay, so what I was doing, I said that always we'll keep our object in front of the mirror, and we know that in front of the mirror means negative side, and we get the image either front of the mirror or back of the mirror. We get the image. So if you get the image at front means negative side, so V is negative. If you get the image at back, then V is positive. Okay, Samadhita, yes sir, but in book, no sir, 4 given. Okay. That also I'll discuss. That symmetric, non-symmetric something is there. That is not in your syllabus. Actually, this is totally out of your syllabus. That's given extra in your book. Okay, don't worry. That is in your book. Extra things are given, which are not there in the syllabus, and this time ICC has reduced the syllabus also. So many things are reduced from your syllabus. So don't worry, whatever I'm covering, just go through that. Okay, don't worry, whatever I'm teaching you, just go with that, because this time ICC has also cancelled few things from your syllabus. I'm not saying so many things, they have excluded very few things, which we'll not discuss also. Okay, fine. So try to understand this. So we have understood this, but one thing I shown you in the third video about this type of ray diagrams. Lot of ray diagrams we discussed. And do you think that always you get the straight image? I mean this way. Sometimes you get this way also. No, sometimes you get the image this way also. This is the image or this is the image. I mean to say downward, not always upward. Here I have shown upward, but sometimes you see the image is forming downward also. Image is forming downward also. I told you that in the third part of the video. Okay, sometimes the image, it's not always image will form upward. Like I want to give you an example. If you I think you have realized that also. Say in the plane mirror, if you stand straight, you will see that your image is also straight. Okay, so if this is the object in the plane mirror and this is only the image in the plane mirror, but if you are standing in front of a spherical mirror, if you go to a science city of Siliguri or any other city, if you go to a science city, you will see that concave mirror, convex mirror are kept. And if you go in front of a concave mirror, say Sudhanshu Pradhan is standing in front of a concave mirror or convex mirror, then he may notice his image is totally ulta. Another ulta Sudhanshu Pradhan is standing. Ulta. Okay. So that is also possible. In plane mirror, it is not possible. Plane mirror always you see the straight Sudhanshu Pradhan. But in case of convex mirror or concave mirror, you may see another Sudhanshu Pradhan is there, but that is ulta. Okay, upside down. Okay. So this is another case. Here we need to discuss that sign convention in that case also. So here, try to understand this condition. All of you try to understand this condition. But I cannot keep my object ulta like this. I will not keep my object like this. Never. I will keep my object always straight. Because you cannot stand ulta in front of a convex mirror. We'll never take it. Always will keep our object straight in front of a mirror. Okay. Always will keep the things straight. So I'm keeping the things straight. Okay. Now I'm saying you something you must remember. If you keep your object upward, like up, it's always positive. If you see it's down, negative. What I said? Up means positive, down means negative. Like this. Try to understand what is written here. Up means positive and down means negative. Okay, positive, negative. Now see, object always we keep upward. Okay, object always we keep up. So this is called, when we are keeping always the object like this is always positive. Okay, see here the image is forming this way, so this is positive, this way is negative. This way is positive, but this is negative. Okay, this is called what image? Can you answer me? This one, what image is called? This one, if you know the answer, because we discussed in the third video. If you know the answer, write it. What image it is called? Yes, erect image. Erect image, correct. Ankit Gupta has written Srija De. Erect image, correct. Erect image. And this is what is called? This one. Yes, erect image. This one, what is called? This image. Can you answer me? Inverted. Yes, Riddhi Agarwal said inverted image. So this is erect image, this is inverted image. And we call it height of the image. Okay, this is called height of the image. Understood? Yes, correct. So now write it down. All of you write it down. Object height. Object height. Object height, you must be understanding with the name object height. Right. Object height, in bracket you write O. Object height O. This is called object height. This one. Okay, this is called object height. This height. Object height. So, write object height, in bracket you write O. O. Equal to positive. Always positive. Because always we keep our object like this. We'll never keep your object like this. Always we keep our object straight. So object height in bracket write O equal to positive. Always object height is positive. Now next line you write image height. In bracket you write I, capital I. In bracket you write capital I, image height, equal to positive. Equal to positive. When image height is positive, see, this is the image. When your image height is positive, this, see, upward means positive. Upward means positive. So your image height is positive, then this is called erect image. Understood? Erect image. So write image height in bracket you have written I, bracket close, equal to erect, positive, sorry, positive, then write erect. Okay, so when image height is positive, it is called erect image. Next line you write, next line, image height in bracket you write I, capital I, not small I, capital I. Image height in bracket capital I equal to negative. Means this is not the image, this is the image. Okay, ulta image you are getting. Image height inverted, beside you write inverted. Okay, inverted. Understood? So this is the thing. So what I told you in sign convention, see, sign convention is very important, because after that we'll start numericals, and when we'll start numericals, these things will be required there. So if you have got a very clear idea on this sign convention, then only you will can get those numericals very clearly. This numerical will come in exam, 5 marks. It's a long numerical, lots of ideas are there. I'll tell you so many small things. If you write those things in exam, then only you will get 5 full marks. Got it? So for that, it's very important to understand sign convention of mirror. That's why I'm taking this live class, so that you can understand this sign convention very clearly. So for sign convention, first we have discussed about object distance. Object distance is you just match your list which you have just written, the list which you are making now, students, which the list which you are making now, you just find out how many books you want to find in your school library, or the books which you have at your home, or anywhere, any library. You just search the book, you will not get the whole list together. You will get all these things at different places of your book, of the chapter, different places now, but not all together. So this list is very important. In this list, what I said, first just match it. First I said object distance u equal to negative. Just see it's matching or not. Next line you have written image distance v equal to positive, virtual. Image distance v negative, real. Okay, so third line was object image distance v negative, real. Okay, understood or doubt? The first one was object distance u equal to negative. Second line, image distance v positive, virtual. Third line, Image distance. No doubt. Okay. Samadhita, where is the doubt? Doubt. Okay. Samadhita. Okay. Oh, acha, no doubt. Okay. Samadhita said no doubt. Fine. Thank you. I thought you have got some doubt. Okay, no problem. So what I said, just match it. First line, object distance U, negative. Okay. Image distance V, positive. Virtual image. Image distance V, negative. Real image. The next, object height. Object height O equal to positive. Next line, image height I, capital I, equal to erect image. Image height I equal to positive, erect image. Okay. Image height equal to negative, inverted image. This much you have done. Okay. Now, if I draw a concave mirror, I'm drawing a concave mirror. I know which is my negative side and which is my positive side. I know negative side in front of the mirror is always negative. Back of the mirror is always positive. So if you see a concave mirror, see I have drawn a concave mirror and I have shown the position of focus and center of curvature. See this is my spherical mirror, this is my concave mirror. I know that this is negative side, this is positive side, and this is center of curvature. This is focus point. That means this is radius of curvature, R, radius of curvature. So radius of curvature is at negative side, and this is called focal length. Focal length is also at negative side. That means for a concave mirror, radius of curvature and focal length both are at negative. Understood this? Right. For concave mirror, write it down. For concave mirror, radius of curvature, in bracket you write small r, radius of curvature small r, and focal length, in bracket you mention small f, okay, bracket close, r negative. Okay, you have seen how this concave mirror, this is negative. Now I will draw a convex mirror. Convex mirror. See, this is convex mirror. Negative side, positive side. Okay, negative side, positive side. Focal length and radius of curvature both are in the positive direction for a convex mirror. Okay, for a convex mirror. So write it down. For a convex mirror, radius of curvature and focal length both are positive. For a convex mirror, radius of curvature and focal length both are positive, this much. Okay. So the things which we have discussed, this is called sign convention. And I told you that you search any book, you will not get the whole list together, the list which we have prepared now. You will get each and everything in the chapter, but some in say in this page, some other in that page, in that way, but not, you will get not get this in all together. So we have made the list. This is the main things of sign convention. Okay, after that we'll discuss the formula, then we'll discuss the numerical. For that I made a video for you. I will share this video with you on most probably on this Monday. Okay, Monday or Tuesday I will share this video with you. Okay, so this is the thing. Now we will bind up this class here. Now all of you just write your name once in the comment section, and then you can leave the class. Thank you all of you.